Hi Neet Aspirants, welcome to Vari Medical Academy. Vari Medical Academy சார்பாக அனைத்து விதமான டாபிக் சார்ந்த ஒவ்வொரு வீடியோவும் இனி வரும் நாட்களில் உங்களுக்கு வரும். உங்களுக்கு இதை சார்ந்த சந்தேகங்கள், கேள்விகள் எதுவாக இருந்தாலும் கமெண்ட்ஸில் பாஸ் பண்ணுங்கள். எங்கள் எக்ஸ்பர்ட் ஃபேக்கல்ட்டி மெம்பர்ஸ் போடுற வீடியோஸ் பிடிச்சிருந்ததுன்னா ஷேர் பண்ணிக்கோங்க. அந்த வீடியோ ரெகுலராக உங்களுக்கு வரணும்னா சேனலை சப்ஸ்கிரைப் பண்ணிக்கோங்க. தேங்க்யூ. Wish you all the best.
Yeah, good morning students. How is your preparation of Neet 2023 exam? And I already given more videos on chemical bonding, and today topic is dipole moment. Right ma? Dipole moment. Dipole moment. Dipole moment, it can be denoted as the symbol mu. In some books it is denoted as P also. Dipole moment, already we explained the percentage of covalent character in ionic bond explained by Fazan's rule, percentage of ionic character in covalent bond explained by dipole moment. Whether 100% covalent bond, 100% ionic bond is not possible. Some percentage of covalent character, some percentage of ionic character also present. Whether molecule is polar and non-polar, we will decide. The dipole moment will decide the molecule is whether polar or non-polar, will decide by dipole moment. Now write, dipole moment will decide, dipole moment will decide whether molecule is polar or non-polar. Please remember this point. Whether molecules are polar or non-polar will decide by dipole moment. For example, we can take this one. Here is the benzene to dichlorobenzene. Here is para-dichlorobenzene. Here is angle is 180 degree. Here is the dipole moment, that is the dipole moment is 0. Mu net is equal to 0. The molecule will be non-polar. If you take any molecule, if you take a water molecule, in a water molecule also dipole moment will decide. Here is, this one is a polar molecule, this one is polar molecule, this one is non-polar. This one explained by dipole moment will decide the whether molecule is polar and non-polar. Now one by one we can discuss. And dipole moment is denoted as symbol mu. That is dipole moment is denoted as symbol is mu. Now it is a vector quantity. The dipole moment is a vector quantity. Dipole moment is denoted as mu, or some books P, and mu is the dipole moment, and it is a vector quantity. You know vectors in the opposite directions. In opposite direction vectors, here is cancelling with each other. Here is a cross lined on positive end, head on negative end. These two opposite vectors are cancelling. Now this is the vector quantity. Now dipole moment, the unit is dBi. dBi is the unit of dipole moment. The dipole moment, dBi is the scientist. 1 dBi is equal to 3.33 into 10 ki power minus 30 coulomb and meter. Coulomb C denotes as charge, M denotes as internuclear distance, that is a M. Now Now dipole moment mu is equal to q into d. Now dipole moment mu is equal to q into d. What is q? Charge on atom. Charge on atom. The charge is present na, that is charge on atom, and d is the internuclear distance. Internuclear distance. Internuclear distance. Now please remember, dipole moment is denoted as mu. Whether molecule is polar and non-polar, dipole moment will decide the whether molecule is polar or non-polar, and it is a vector quantity, and it can be measured in dipole moment. Measured unit is dBi. 1 dBi is equal to 3.33 into 10 की power minus 30 coulomb. C means coulomb. Charge measured in coulombs and distance measured in meters. Now the mu is equal to q into d. Now q means charge on atom, d is equal to internuclear distance. Now we can write it. If I am taking H and F, H and F, here which one is the more electronegative? Hydrogen is less electronegative, and fluorine is more electronegative. The dipole moment from less electronegative atom to more electronegative atom. Less electronegative atom to more electronegative atom. The crossed line, the crossed arrow line present on positive end. The head is present negative end. The direction from head is less electronegative to more electronegative. Less electronegative to more electronegative. The dipole moment can be, we can denote it as like this: the crossed line on crossed arrow on less electronegative and head on more electronegative. These are the important points of dipole moment. Now one by one we can discuss the molecules. AB type, AB2 type, AB3 type, AB4 type. We can one by one we can discuss dipole moment. It's very important chapter for preparing Neet or JEE exams. Okay. Now we can take examples. For example, mu net, total resultant, mu net, that is equal to, not individual, mu net. Mu net is equal to 0. That molecule will be non-polar. Remember these points. Mu resultant, total net, mu net is equal to 0. That molecule will be non-polar, not individual vectors. Okay na? Mu net. Now mu net resultant vector not is equal to 0. That molecule will be polar. If symmetry is present, that is symmetrical. If surrounding atoms are same, write this point, symmetry is present, surrounding atoms are same, no lone pair, that is equal to mu net is equal to 0. That molecule will be non-polar. Remember this point. If lone pair is present, lone pair is present. Now lone pair is present means mu net not equal to 0, that molecule will be polar. These points remember, not individual vector, resultant mu net is equal to 0, that molecule will be non-polar, and mu net not equal to 0, that is polar. Now symmetry is present, that is symmetrical, tetrahedral and trigonal bipyramidal, or any symmetry is present, surrounding atoms are same. If central atoms, surrounding atoms are same, but central atom is different. No lone pair, that is mu net is equal to 0, that molecule will be non-polar. Next one is lone pair is present, mu net not equal to 0. Lone pair is present, mu net not equal to 0. But xenon compounds means xenon tetra, xenon F2 and xenon tetra fluoride, these two. But lone pair also present, lone pair is present, again mu net is equal to 0. This is the exceptional. Please write down exceptional. Which one is the exceptional? Xenon compounds. Xenon F2, xenon F4, lone pair is present, that mu net is equal to 0. Now what are the important points? Now mu net, mu resultant, total resultant, not one individual. Mu net is equal to 0, that molecule will be non-polar. Next, mu net not equal to 0, polar molecule. And symmetry is present, surrounding atoms are same, that no lone pair, that is non-polar. If lone pair is present, mu net not equal to 0, this will be polar. Now exceptional, please write down exceptional. Xenon compounds, xenon F2, xenon F4, lone pair is present, mu net is equal to 0. Now already we discussed from the dipole moment, from this is a cross arrow, here is a positive end, here is a negative end. Now the dipole moment is less electronegative atom to more electronegative atom. Less electronegative atom to the crossed line on positive end, head on more electronegative atom. Due to the electronegativity, there is a poles, negative pole and positive pole is formed. What is electronegativity? Electronegativity means the relative tendency to attract the shared pair of electrons or bonded pair of electrons towards itself. That is more electronegative. If atom is there, a lone pair is present. Atom and lone pair is present. Now dipole moment from atom to lone pair. Atom to lone pair. Now crossed arrow, crossed line, that is positive end, and this one is the negative. Now atom to lone pair. Less electronegative to more electronegative. These points you have to remember while you are doing the examples. It is very, very important. Please write down this. Mu net is equal to 0, non-polar. Mu net not equal to 0, polar. And symmetry is present. Surrounding atoms are same. No lone pair, that is mu net is equal to 0, non-polar. These are the points are very, very important while you are any molecule you are practicing, but the maximum chemical bonding every year they are given question 3 to 4 question, whether MOT they are asking, whether structures and geometry or VSEP or hybridization or lattice energy, whether dipole moment, the maximum they concentrate the dipole moment. This is the vector quantity. Next, we can take examples how the molecules are polar and non-polar. We can take example one by one. Homodiatomic molecules, we can take it. First one is homodiatomic molecules. Example, write down. Homodiatomic molecule. Homodiatomic molecules means I am writing H2, comma Cl2, comma Br2, comma I2, and this type of homodiatomic molecules, mu net, mu resultant or mu net is equal to 0, that molecules are non-polar. Non-polar. Remember this one. First point is hydrogen H2 dihydrogen Cl2 Br2 I2 N2 O2, mu net is equal to 0, that molecule will be non-polar. Heterodiatomic molecule I am writing HF, next one is HCl, next HBr, next one is HI. Here, which one is more less electronegative? This hydrogen is less electronegative, fluorine is more electronegative. Now we can write the dipole moment like this. From crossed line, the crossed arrow line on positive end, and this is head on negative. Now here also hydrogen to chlorine, here hydrogen to bromine, here hydrogen iodide, here also hydrogen and iodine. Iodine is more electronegative, that's why more electronegative means head, less electronegative means cross line. Less electronegative to more electronegative. Now, which one is the more dipole moment? Dipole moment is directly proportional to electronegativity of atom. If electronegativity is increases, fluorine is more electronegative compared to iodine. Which one is the more distance, bond length? Hi is the more distance. Which one is the charge? Charge is the predominating factor. Distance is not. Charge only dominating factor for dipole moment. Now, heterodiatomic molecules, these are in this molecule mu net not is equal to 0, that molecule will be polar molecules. These all are polar molecules. Remember, dipole moment is directly proportional to electronegativity. Now I am taking AB2 type molecule, AB2 type. If I am taking AB2 type, example, tell me CO2 I am writing, CO2 and C2H2, next one BeCl2, BeCl2. First one, take the carbon dioxide. Now carbon dioxide structure, tell me linear. Now linear structure, the surrounding atoms are same. If surrounding atoms are same means, here which one is the more electronegative, carbon or oxygen? Oxygen is more electronegative. That's why the dipole moment from here to here. Here less electronegative to more electronegative. Here also less electronegative to more electronegative. This opposite vectors. Now mu net, they are cancelling. Mu net is equal to 0. Now CO2 is non-polar. This one is non-polar. Why, sir? Because less electronegative to more electronegative. Less electronegative to more. There are opposite vectors. Opposite vectors, you know, in physics, opposite vectors are cancelling each other. Mu net is equal to 0. That molecule will be non-polar. If you take C2H2, I am taking C2H2, hydrogen, C triple bond, CH. In this also, which one is more electronegative? Carbon is more electronegative. That's why here is less electronegative to more electronegative. Here also less electronegative to more electronegative. Now mu net mu net is equal to 0, this molecule will be non-polar. Non-polar. Understand, students? Here is opposite vectors, here also opposite vectors. Now I am taking BeCl2, Be and chlorine, here also chlorine. Now here also beryllium to chlorine, here also beryllium to chlorine. The less electronegative to more electronegative. Now mu net is equal to 0. This molecule will be non-polar. These are the AB2 type molecules. AB2 type molecules. AB2 I am taking CO2. Why sir CO2 is 0? Because this is a less electronegative, this is more electronegative. They are opposite vectors, they are cancelling. If you take C2H2 also opposite vectors, they are cancel each other, mu net is equal to 0. That molecule will be non-polar.